Okay, welcome to our first ever astronomy lesson together. We are going to be starting a new notebook, a new subject, a new unit. We're starting our astronomy unit. We've just finished up our introduction to science unit. Your test was yesterday. You guys did pretty well on the test. The issues that I did see were the students who struggled the most were the ones that were not following along every day, not keeping up with their notes, and that really hurt them in the end when it came time to take the test. So please make sure you're watching the videos, completing your notes, and doing your assignments and keeping up with our day-to-day school. Just because you are not in the schoolhouse does not mean that you don't have schoolwork to do, right? We're trying to come up with ways that are going to make it more streamlined, easier for you to realize and understand your expectations. But as for now, we're just going to keep trucking as is. So here is our home page. Today we are actually going to have a Zoom meeting. So we have a Zoom link from 9 to 9:50. We'll have that meeting. If you want to join, just push the link. This is going to be used today for any questions you might have, as well as a time to just drop in and talk about science. If you don't have any questions, you could keep trucking along as is. So if we go into our modules, tomorrow you will see a day 3 there. Yesterday, like I said, we took our test. We were also sorted into teams for a activity that we're going to be doing all school year as far as earning points. Similar to how similar pretty much to Harry Potter and how the houses win, right, every year. So we're going to be doing something similar to that. Your notebook, if you need a copy of it, is the very first thing in week 4. If you aren't face-to-face, I've already given you a copy. Go ahead and pull that out now. It looks like this right here. And this notebook is a little different, as in each day has a little checklist for you of your expectations. There might be some things added or taken away. It just depends, and I will always let you know. But as a general rule of thumb, you need to think of this first page as a checklist, right? And it continues on to the next page. So if you will, go ahead and grab out those notebooks for us. We're going to start, as always, with our vocabulary. Our vocab today is going to be short, sweet, and to the point. Today you are going to be writing down the definition for me, please, of radiation and galaxy. Give me one more second and I will present it again for you. Pause the video so that you can get down the vocabulary. As always, it goes in your vocab section of your notebook. When you're ready to begin again, just unpause the video. Okay. Ellipse is going to be for tomorrow. Please don't do it. Here's your bell ringer. Please place these in order from largest to smallest in your bell ringer section of your notebook. Your bell ringers. Your bell ringer section looks like this. Today's date is September 2nd. If you will, place those in order from smallest to largest, and then please answer the question, what shape of the planet, or what is the shape of the planets that orbit around the sun? So what shape does the path take? Pause this video to write down your answers. To go over the answers with you, the very largest here is universe. A little bit smaller, the universe is made up of galaxies. Galaxies are made up of solar systems, and solar systems are made up of planets. The shape that the planets take when they orbit the sun is an ellipse. An example of an ellipse is a circle. We'll learn in just a little bit. These are our notes for another day, so we're going to skip through them pretty fast. Ta-da! So now, if you will, turn in your notebooks to the origin of the galaxy. They are guided notes. In my notebook, they are not labeled with page number. They look like this. That's where we're headed. Okay? So the origin of the galaxy and solar system. Before we have the model that we think of now of our solar system, we used to have this model called the geocentric. We learned in our prefixes and suffixes that geo stands for Earth, centric looks like circle or center. In this case, the Greeks and the predominant theory of the time was that the Earth was the sphere that stayed motionless at the center of the universe. So everything revolved around the Earth is what we thought at first. So if you will write that definition down in your notebook, as always, pause me as needed, but we're going to keep going. So as with science often is, we find new evidence that supports a different idea, and we often find that the old theory is no longer supported with evidence as technology advances. So Aristocratus was the first Greek to believe in the heliocentric model that the Earth and the other planets orbit the sun. Modern astronomy started with Nicholas Copernicus. So Aristocratus and Nicholas Copernicus, they helped coin and find evidence that supported this heliocentric or sun-centered model of the universe, and that is actually the predominant theory that we think today. So we no longer believe that the Earth is the center of the universe. We now, the evidence supports that the sun is now the center of the universe and the solar system in this case, right? The heliocentric system, so Aristocratus was the first to think it and believe it. Copernicus is credited with the idea of it because he found evidence to support it. So Copernicus proposed a heliocentric view of the solar system to explain the motion of the planets. He said, this isn't moving the way that it would if the Earth was in the center of the universe or solar system. So there's got to be something else going on. And eventually he was able to support this idea with scientific evidence. In science, we have found evidence that supports that the universe began as a Big Bang, right? So the current understanding of how the universe began is described by the Big Bang theory. It actually wasn't that big, and there really wasn't a bang. Okay? This is the idea that at 1 second there was nothing, or a small dust particle, and then suddenly, bang, we have the universe, and it has been expanding ever since. That's what this is showing you. There was an explosion, and our universe has been getting larger and larger ever since. There's more on the Big Bang Theory. If you'd like to watch the video, you're welcome to. If not, we're going to keep trucking. So this theory states that the universe began from an initial point or singularity, which has expanded over billions of years to form the universe as we know it today. So basically, at one point in time, there was something very small, or an initial point, which has been expanded until we get to the universes that we see today, or the universe and the galaxies and solar systems that we see today. The universe we live in is expanding. We know this because of some scientific evidence that we're going to see on the next couple of slides, but it's called the blue light versus red light shift. We know this also because we see galaxies and groups of galaxies steadily moving apart in the universe. So we have been tracking ever since technology has increased enough to give us telescopes, but also more high-powered telescopes. We are able to track the distance of the galaxies from us to the galaxy, and we have concluded that they are moving further apart. This expansion has been occurring ever since the universe was formed 14 billion years ago, right? Just like the theme song of the Big Bang Theory tells us. We know this. This is the scientific evidence that I was talking about. This is what scientists use to support the idea of the Big Bang Theory. It's called the Doppler effect. So stars moving away from us appear red. Stars moving towards the observer appear blue, and we call this the red light shift or the blue light shift. And when we are looking at stars in a high-powered telescopes that are going that are out in the night sky, we see that they have a redshift light, indicating that they are indeed moving further away from us. So here's just an example of what it would look like. So if it were unshifted, if we were looking at this point in time, we would see that color, but because of the shifts, we are getting different colors than what we would expect, right? More on the Doppler effect. So this is due to a change in the wavelength of a wave from a source as it moves away from or towards an object. When a light source is moving towards the observer, the wavelength is shortened, i.e. becomes blue, right? Blue light is more high-powered and has a smaller wavelength than a red light. So when the light source is moving away from the observer, the wavelength lengthens, therefore becoming more red because the wavelength is larger on a red wave than it is a blue wave. Let's talk about the nebular theory for a second. So nebular theory is the theory of how stars and star systems were formed. It is the most widely accepted scientific explanation of how stars came to emerge from the cosmos. Gaseous clouds or nebulae, which slowly rotate, gradually collapse and flatten due to gravity and eventually form stars and planets. This is how we believe that the stars in the solar system surrounding the stars and galaxies that contain solar systems were formed. They once all began as this gaseous cloud, and then it started rotating and it gradually collapses and flattens due to the gravity and will eventually form the celestial bodies of stars or planets. It is the most widely accepted scientific explanation, but as we know, science is dynamic, it is constantly changing, so the evidence we might find later on might not support this theory, and we would reevaluate and reword or rethink this theory. So more on the solar nebular theory. All solar systems start as clouds of gas and dust called nebulae. Gravity and centrifugal rotation compress dust and objects, stars, moons, and planets, until they become what we know today as the celestial objects of stars, moons, and planets, asteroids, etc., the solids of space, or gases, because some planets are gases. Again, please, please, please remember that the Earth revolves around the sun. This is what's going to go in the very bottom of your notes. Right here. Right there. Thank you. So the Earth revolves around the sun. The sun revolves around the galactic center of our galaxy. By the way, our galaxy is called the Milky Way, and it is formed as a spiral galaxy. We'll talk more about that later. And then galaxies are moving away from each other in the expanding universe. What is the difference between the solar system, galaxy, and universe? Basically, the size is the biggest distinction. That was our bell ringer question of the day. So we live on a planet Earth, which is part of our solar system. And then our solar system, including the sun and everything that orbits the sun, is part of the Milky Way galaxy. The Milky Way galaxy is just one galaxy in the universe. So if you were listing these from smallest to largest, you would start with planet or star. And then the planets and stars together, they make up the solar system. And then the solar systems together make up a system of galaxies, a system that we call a galaxy. And then the galaxies together make up the universe, right? So that very last part of your notes is asking you to please write down from largest to smallest: galaxy, universe, galaxy, solar system, and planet. And that is all we have for our lecture today. Make sure to take a picture or a screenshot of your notes and submit it into Canvas under your assignments, right? Have a great day, guys.